Characteristic of sound. A sound can be characterized by the following three subjective properties. Subjective properties are the properties which depend upon observer or listener. Number one, loudness. Loudness unit is decibel or phone. Number two, pitch. Pitch or shrillness. Number three, quality or timbre. Now, there are two objective properties. Objective properties which depends upon the instrument producing sound. Say guitar, sitar, violin, harmonium, tabla, dholak, they are producing sound. And objective properties depend upon these instruments. Number one, intensity. Unit is watt per meter square. Watt is equal to joule per second. Therefore, it may be joule per second per meter square. And second is frequency. Unit is hertz. Loudness. Loudness is a subjective property of sound that depends upon the listener who is listening the sound observer. We have seen in the old days some persons are using ear machines for listening the sound. That is, the sound is magnified, amplified we can say also by the machine, and loud sound is observed to the observer in the old age. Therefore, it depends upon the observer and it is a subjective property. Let us repeat. It is a subjective property of sound by virtue of which a loud sound can be distinguished from a faint. Faint means weak sound, both having the same pitch and quality. The unit of loudness is decibel, dB. Loudness depends upon intensity, and intensity at zero level loudness is given by I0 is equal to 10 to the power minus 12 watt per meter square, whereas intensity of sound I is at any other level required to calculate or given. Then relation between loudness and intensity is given by the formula dB means loudness in decibel is equal to 10 logarithm I upon I0, where I0 is intensity at any level which is more than the zero level intensity. Sound of loudness greater than 120 decibel, dB for decibel, is termed as or known as noise. Loudness depends upon number one, amplitude. Amplitude is maximum displacement of medium particle from their mean position. Mean position is shown here on x-axis and vibration in y-axis. In figure 1 there is less amplitude, in figure 2 more amplitude. Therefore, more amplitude gives here more loudness, and sound of more loudness is in case 2, that is louder sound shown in figure. Number 2, distance. Area 1, area 2, area 3 are showing here different distances from the source producing sound. On increasing distance, the loudness decreases. Number 3, surface area. A smaller surface area in figure 1 gives a soft sound. Larger surface area in figure 2 gives a loud sound, and two tablas are shown here in the figure. Therefore, this is clear that on increasing surface area, loudness increases. Number 4, density of medium. On increasing density of medium, loudness increases. Pitch. It is a subjective property of sound by virtue of which an acute or shrill thin sound note can be distinguished from a grave or flat sound. A sound of higher frequency has a higher pitch. High pitch sounds are sweet and pleasant, and low pitch sounds are unpleasant. Example, sound of mosquito is of high frequency and pleasant, but the sound of a lion or cow is of low frequency and unpleasant. High frequency, low frequency waves are shown in figure. At the top, time period is less, frequency is high, because frequency is reciprocal of time period. In the figure 2, time period is more, frequency is low. Formula is again used here. Frequency is equal to 1 upon time period. Frequency low means pitch of the sound is low. Frequency high, number of loops in the given distance are more. Higher frequency, pitch is high. In the figure 3, combined low and high pitch are shown. Low frequency in the first half, low pitch. High frequency in the second half, that is high pitch. Quality or timbre. It is a subjective property of sound by virtue of which two sounds of same loudness and same pitch but emitted by different instruments can be distinguished or identified. Quality depends upon the shape of instrument, and different shaped instruments produce waveform of different shapes. Therefore, quality is different. Quality of sound depends upon waveform of the sound. In orchestra, different shapes of different instruments produce different waveform of the sound. Therefore, on the basis of waveform formed by the instrument, sound of different instruments can be identified. Quality of sound, that is different waveform. In the figure 1, 3 sounds of different waveform produced by different instruments are shown. Here, the shape is different. It means instrument shape is also different, and different waves of different shape are identified, although all the instruments are sounded together. In the figure 2, two waves of different shapes are shown. They have different frequency or pitch, and loudness is almost same, but the quality of the wave is different. In orchestra, there are many instruments: sitar, violin, guitar, tabla, dholak, flute, trump, and others. but we can identify these instruments due to presence of different shape of the wave, that is waveform is different, and it is it is clear that shape decides the quality. Intensity of sound. Definition: amount of sound energy passing through one unit area perpendicular to the direction of propagation. Propagation means traveling of sound in 1 second is termed as intensity. Here figure shows here different areas at different distances, but ultimately 1 unit area is required. Therefore, intensity is calculated for 1 unit area, the energy passing in 1 second. Arrange the following in order of increasing: number 1 loudness, number 2 pitch. Answer: number 1 loudness. Loudness depends upon amplitude. Amplitude means displacement, maximum displacement. Maximum displacement from mean position. And in figure 1, displacement in y-axis is least. It is slightly more in figure 3. Therefore, loudness is more in figure 3 in comparison to figure 1. It is more in figure 4. Loudness is more in figure 4 in comparison to figure 3, and highest in figure 2, that is loudness is highest in figure 2 and it is least in figure 1. Second, pitch. Pitch is based on frequency. Lowest frequency, lowest pitch. Highest frequency, highest pitch. And frequency is reciprocal to time period. Therefore, we can check time period. Time period is more, frequency and pitch is less. Time period is less, frequency and pitch is more. In the figure 3, more time period, low frequency, low pitch. In figure 2, comparatively higher frequency, high pitch. In figure 1, more than 2. Frequency is more than figure 2, therefore more pitch. And in figure 4, frequency is highest, pitch is also highest, and time period is lowest, as shown in figure. Human ear. Diagram of human ear is shown in the figure. The outer part is pinna and it is collecting sound waves coming to ear canal. Then there is eardrum and it is connected to the liver inside middle ear, and on the basis of vibrations in the eardrum, the liver shrink or expand, give the sensation to the inner ear. Working of human ear. The sound waves are collected by the pinna, that is outer ear, and passes through the ear canal and fall on eardrum. When the compression of sound wave strikes the eardrum, then increased pressure pushes the eardrum inward, and for a rarefaction due to the decreased pressure, the eardrum moves outward. Due to the vibrations of eardrum and liquid in inner part of ear, electrical impulses, that is electrical signals in the nerve cells are carried by auditory nerve to the brain. The brain interprets these signals and gets the sensation of hearing. Thank you.